Hey everybody, this is Larry. This is day 2 of the November Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. We're on Discord, everyone's been posting code and stuff like that, so let me know. Today's problem is 980, unique path 3. I see a grid here. Let's actually read the problem. You're given n by n grid, you're starting, you're ending. You can number 4 directional walks that go from the starting square to the ending square that can walk over every non-obstacle square exactly once. Actually, this was not going to be this is not the problem that I thought it was going to be. I thought it was going to be a standard dynamic programming from this grid, but this one instead is Euclidean square. Sorry, Ham path. Yeah. Basically, this is Hamiltonian path. Am I spelling it wrong? Double check the spelling. Hamiltonian path. Just double check the Hamiltonian path. So that's basically the problem. And one thing that you should know about this one is that, and this is where knowing the literature helps, is that Ham path is of course NP complete or hard. I forget which one actually. Now that I think about it, I think it's NP hard actually, right? Oh, NP complete. Okay, yeah, that's right. Okay, sometimes I confuse them to be honest. It's been too long. But yes, NP complete. That means that there's no there's no polynomial solution, right? There's no optimal polynomial solution. That said, the two things I would do before I kind of settle on, one is see if this is the general Hamiltonian path in the general case is NP complete, but we want to see if this is the general case or there's some like weird thing that we can exploit to make it less than n that makes it not necessarily NP complete. And then the second thing is look at constraints. Look at the constraints real quick, and m times n is less than or equal to 20. So that is I don't know what that means for me. I mean, that means that in theory it should be brute forceable, but honestly it's going to be hard to prove. It is a very small n though, and yeah, and the way that we would think about it with an NP, let's assuming that is NP complete. I don't know. I have to think about it, but it means that we should do brute force, but maybe with pruning to make it slightly faster. I don't know why I'm typing it though. I guess I could just say it. But yeah, but that's basically the idea. And do we start? Okay, we start at 1 and then we go to 2. Okay, so there's no like, I guess what I was trying to see was if there's any I don't know, like left corner, upper left, or bottom right. But knowing that this is Ham path, we can just calculate this. I mean, and this is starting to the end, so that's not that bad. But yeah, but I don't think there's anything else to. So the way that I would say, for at least the way that I usually go about NP complete problems, is quite a little or just do a lot of research, right? Because a lot of NP complete problems, a lot of people have done research and they will, have strategies on how to, make it more efficient, make it and all that stuff like this. And it will still be exponential, but just be slightly faster, right? So, and sometimes that's all you can do, right? Sometimes it could be exponential, but it's twice as fast or takes half as much time. That's a win. So these are the things that you already know that you have to prime yourself for looking for. So yeah, let's get started. So let's find the starting x, starting y, and x and y as you go to just set them to none. We set R as you go to length of grid, C as you go to length of grid sub 0. We'll make sure that this has at least a space, and it does. So yeah, so this should be good. And then we just go in a very loopy thing to set up the beginning and the end. if grid of xy is equal to 1, L if that 2, right? Then ex dy is equal to xy, right? And we can of course set them to 0 afterwards. There's -1 as well, but yeah. I don't know that we need to set this to 0, but that is what I'm gonna do. Just to kind of make sure, just so that there are fewer cases to edge, to have edge cases on. And then the next thing that I would do is, there are a couple of ways you can do it, but one is to make sure, maybe this isn't technically clean, to be honest, because now okay, maybe we won't do this actually, because now we're changing the input, and that's a little bit awkward. But what I was going to say is that you want a data structure to keep track of things that you've seen before, and in this case, like, and in theory you could do in place stuff with grid, but let's just create a boolean array, right? So scene is equal to force times right, something like this, and yeah, and then now we have a recursive function, so we go from xy, say, and of course we have the 4 directional directions. We've been doing this a lot lately, so check out some of my previous videos if you want to go over this, but it just allows us to set up the for loop, which you'll see in a little bit easier. Okay, and then now there's yeah, how do I want to think about it? Let's say we can also, there are a couple of ways to do this, so, and feel free to do it your way, but the way that I'm doing is just making it so that it's a little bit easier for me to check instead of having an looping it to check, right? If I was going to say r times c, but let's call n is equal to r times c, so that we could do something like, if we have taken n spaces, then we the number of them, yeah, and because you have to count the number of them, yeah, brute force is probably the way to go, because there's no way to do it without enumerating it, right? So there's no, I mean, there may be some strategies where you can find one in a quick way, but if you have to find all of them, then in the worst case, there's going to be exponential amount of them anyway. Okay, so let's say this is the case, then otherwise we go for dx dy in directions, and x and y, new x new y is equal to x plus dx, y plus dy. I mean, I usually, and if you've seen my video before, I usually write this roughly the same way. That allows me to kind of be more careful about it, or like, it's just so I don't have to think about it, right? I don't know, that's just something I would say. So if make sure that this is not n1 or -1, because if this is -1, this is not good, and this is not seen, so yeah. Otherwise, so once we can do that, we set scene is equal to true, we go nx and y, take in +1, and then we set it back to 4. So this is just standard backtracking, so we have to make sure that we clear, and I think this is roughly good. That's not true, actually. Give me a second. This takes 1 space, okay, and this is actually, I think I forgot to add something here, which is that if x is equal to x, y and y is equal to ny, then we increment, otherwise we just return. I think this should be good, well, except for I have to probably return. Okay, we just have to do the count. Oh, that's interesting. But also, let's use more test cases. So the answer is 2 and I have 0. Dong dong dong. Huh. Do I have any typos? Maybe this is off by 1. Should be okay. Okay, let's see. I would say we probably could terminate a little early. There are optimizations we can make, but this is as naive as it can get, relatively. But that said, it's wrong. So how does it get 9 here though? What am I doing? Wrong. Dong dong dong. Oh. I forget that this doesn't. This is actually not true. That was a shorthand so that I don't have to do it here. But that's not true because if you have a blocked path, then this is obviously not true, right? Because we can't go all of them. So all we have to do is if grid of xy is not -1, then increment by 1. Okay, and that's why. I don't know if that solves it though. Yeah, because okay, the last one is maybe good, but the second to last one maybe not so good. I think I mucked up a little bit because I should be saying this is the case, so that because I think we end up going again, and it's giving some weird answer because it's double counting that answer. Okay, yeah, there you go. Being a little bit careless here, to be honest. The reason is because I don't like kicking off it like that, but maybe in this one makes sense. Okay, so this one looks okay. So let's give it the worst case, which is easy to do, I think, which is just a 5x4, I would guess, square. So was 5x4 is not a square, but 5x4 rectangle. It should be okay. Let's see, 3, 4. Oh, that's 5. Can't even count. Okay, and then kind of see how it performs time wise, and also maybe see the answers. See how many answers there is. Only 20, huh? This is way fewer than I thought, to be honest. I didn't really do the. I mean, I was a little bit YOLO on analysis because I don't know how to think about it that much. But let's go. Oh, apparently I solved this twice before, and this is the 3rd time. Yay, 3 in a row. Yeah, I mean, I think the first thing is knowing the literature, and I think if you're very careful about it, you can maybe even be better about the bounds. I mean, I can see that there's a lot of what I call self-pruning properties because you can like visit the same path and we do some weird things, like you can't go back into it. And the 5x4 means that, like, if you play the game Snick, it's kind of like you can't cut off these areas, right? So there are a lot of constraints for sure, and seeing that there's only 20 solutions, that's actually pretty interesting. And there are some optimizations that you can make even. I don't know that at least one optimization that I thought that I could make is that, for example, if you go to the exdy, the nxdny before the last step, then we can actually return directly instead of keep on recursioning, which definitely saves time. Maybe not that much time now, that I mean, just because in general it doesn't take that much time, but yeah, yeah, and this is at least the way that we did it is going to be exponential, but there is a lot of self-pruning things, but in the general case it's going to be exponential. Probably something, if I have to guess, something like 3 to the n, where n is the number of open cells or something like that, but with a lot of self constraints, if you will. So in practice it runs much faster. If someone have a tighter bound, maybe let me know in the comments below. But yeah, that's all I have for this one. Let me know what you think. Stay good, stay healthy. Day 2 down. I'll see you later. To good mental health. Bye bye.